This is number 73 in chapter 8. It's asking us to choose which element in the following pairs is going to have the higher first high ionization energy. So we're looking for the higher ionization energy for each one of these pairs, A through D. And so we have to remember the trend for ionization energy, and ionization energy increases as we go up the periodic table and as we go to the right across the periodic table. So that means fluorine would have the highest ionization energy, and francium would have one of the lowest ionization energy. So it's really just looking at each element and where it resides on the periodic table to then decipher which one qualitatively would have the higher ionization energy. And so if we look at the first one, we look at bromine versus bismuth, we see that bromine is much higher up on the periodic table and further to the right. And so as a result, bromine would have a higher ionization energy by where it falls on the periodic table. We look at part B, sodium versus rubidium. These guys are in the same column. They're both group 1A metals. And so which one is above the other? And we see that sodium is much higher on the periodic table than rubidium is. And so as a result, it would have the much higher first ionization energy. With part C, we're looking at arsenic versus astatine. And so what we find is that arsenic is much further up on the periodic table, but astatine is actually further to the right. And so this one's actually kind of a hard one to figure out. But if you then think about the triplet state and realize that arsenic is actually in a triplet state, it has 3 electrons, each in a 4p orbital, and once it loses an electron and ionizes, it actually leaves that triplet state, and that is a large amount of energy. And so arsenic would have the higher first ionization energy as a result of really 2 factors, I think. One is that it's much further up on the periodic table than compared to astatine, and 2, its valence electrons are in a triplet state, and we disrupt that triplet state upon losing an electron. For part D, we're looking at phosphorus versus tin, and we see that phosphorus is much higher up on the periodic table than tin is. We also see that phosphorus is further to the right than tin is as well. And so that means that it's going to be much harder to remove an electron from phosphorus than it is from tin. And so phosphorus would have the higher first ionization energy. So when we're trying to compare ionization energy, we have to really look at where these elements appear on the periodic table with relation to one another. In this case, the higher ionization energy would always be the element that is further up on the periodic table as well as further to the right on the periodic table. That is number 73.